Lesson 6, surface area. So surface area is the total distance on the outside of an object. And when we have three-dimensional objects, we can find the surface area, and a way that we do that first is we find the net. So a net is like if you were to unfold this box, what would it look like flattened out? So if we were to unfold it, we would have an X here, and because there's also one on the other side, we can't really see it, we would have one down here. And we're going to call this A. They're the same shape, just on different locations. The dimensions of this A would be 2.3 and 2.8 meters. So we're going to put a 2.8 here and a 2.3 here. Now when we unfold it, the shape that goes right here has a width of 2.8, so that would be like this shape right here on the front. So this one has a height of 2.8 right here, and the width would be 4.4 yards. So we're going to call this shape B. We've got one right here. We also have one on the back. The exact same shape. And it would be, if we were to imagine this three-dimensional, it would be this shape right here. So both of those are going to be shape B. The last shape we have is this top section right here. And it attaches to both of the B's, and we're going to call it C. And its width is 4.8, which is right. And because this side would fold together to make this side, our other missing dimension would be 2.3. So we have one here. We also have one on the bottom. So there's two C's as well. And all of them have this length to be 4.4. So when we're finding the surface area for this shape, we're going to add two A's, two B's, and two C's. Because A is a rectangle, we would do 2 times length times width. Because B is a rectangle, we would do 2 times length times width. And because C is also a rectangle, we would do 2 times length times width. Now we just need to know our length and our width. So for A, my length could be 2.8 and my width could be 2.3. It doesn't matter which one is which because you're just multiplying. For B, my length would be 4.4 and my width would be 2.8. And for C, my length would be 4.4 and my width would be 2.3. So we're going to do each section. So we have 2 times 2.8 times 2.3 plus the blue section, 2 times 4.4 times 2.8 plus the orange section plus 2 times 4.4 times 2.3. And if we do each section individually, we'll multiply them each individually. This would be 2 times 6.44 plus 2 times 12.32 plus 2 times 10.12, 1, 2. So this simplifies to be 12.88 plus 24.64 plus 20.24, and altogether the area would be 57.76 yards. And because we're dealing with an area, it's square. So that is your surface area for that box. Okay, a canning factory wants to use as little metal as possible to make its cans. It considers two can sizes that hold the exact same amount. One is 4.5 inches tall with a radius of 4.2 inches, and the other is 9.6 inches tall with a radius of 2.8 inches. Which cans should they use? So when we're dealing with a cylinder, we've got two circles, one on the top and one on the bottom. So our surface area first is going to be 2 times pi r squared. And then we also have the outside. And the way that we find the outside is we multiply 2 times pi times r times h. So that would find the outside. And the reason why it does is you take your circumference, which would be 2 pi r, and you times it by the height. So this is the formula for the surface area of a cylinder. So the first cylinder, we have a radius of 4.2 inches. So we would do 2 times pi times 4.2 squared plus 2 times pi times 4.2 times our height, which is 4.5. So it would be, to simplify this down, you would do your 4.2 squared, so type 4.2 squared, times that by pi, times it by 2, and you should get 110.8. And then 2 times pi times 4.2 times 4.5 should be 118.7. So altogether, this is 229.5 inches squared. So that's the surface area for the short can. For the tall can, we're going to use the same formula, except we're using a new radius. So we have 2 times pi times 2.5 squared plus 2 times pi times 2.5 times 9.6. When we type the first one in, we'll do the 2.5 squared first, then times it by pi, then times it by 2, and you should get 49.2. For the second part, we do 2 times pi times 2.5 times 9.6, and you get 168.8. And altogether, that equals 218 inches squared. So you would want to use the thinner, narrow can, because you would use less metal to make that can while still being able to hold as much volume.